Hello, everyone. Today I'm here to present the top 10 things to know about machine learning, the second part of the series. My name is Carlos Bossi. I'm a managing partner with Dataleer. At Dataleer, we're a data engineering and data science consulting company that provides data architecture solutions for you. Well, now we're going to start with number 6. You don't have to be a data scientist to implement machine learning. A data scientist needs a number of skills, and the skill set is quite broad. Data scientist is a person employed to analyze and interpret complex digital data and requires statistics, machine learning optimization, programming skills, visualization, business skills, big data, communication, and storytelling. Quite a large skill set. The following slide shows the skills and how they compare to an analytics job versus a data science job for a data engineers and data analysts. And as you can see all the way to the right, the domain knowledge and skill set for a data scientist is quite large. So why don't you need to be a data scientist to implement machine learning? Well, today there's a number of different ways to do that. As a data engineer, APIs can be used that are provided in the cloud that can provide a lot of benefit to you, whether it's translation services, vision services, and that sort of thing. Uh, a data scientist, the output of what a data scientist does requires a lot of data engineering work and the input as well. And so there's a lot of different ways to work with and be involved with data science without being a data scientist. Today, you probably have data that can be optimized with machine learning. Machine learning and data make for a perfect marriage. And the characteristics of a data ecosystem is that you use both internal and external data. You use data integrated from multiple departments and multiple data sources. You use all types of data, structured, unstructured, image, and voice, and you can support any amount of data. Today, most organizations have much of the data they need to implement advanced analytics and data science solutions, and could do so with what they've been collecting now for years. So many organizations are on the threshold or are ready to do this. And it's just a matter of organizing the data properly, managing it so that it can be used for data science. Machine learning should be operationalized in order to take full advantage of its power. What do we mean by that? Well, here's a good comment from Price Waterhouse that recommends adopting AI in two different streams. One in operational areas to demonstrate the tangible benefits of AI, and the other in emerging areas to demonstrate the value of innovative insights. Once a data science solution is put in place, it must be operationalized to take advantage of it. This way, employees within the organization and anybody else can take advantage of what the data scientist does. Without operationalizing it, it doesn't have the benefits that it would have otherwise. This diagram shows an example of how we at Dataleer would operationalize a data science solution. Uh, on the left-hand side, there's a bar over here on the right side of the screen. On the left-hand side is all the data that gets put together and transformed in a way so that it can be analyzed and evaluated and used by a data scientist. But on the right-hand side is the output of that. Once a data scientist produces a predictive model, it can be then put in production and utilized by applications and reports. Of course, the data still needs to be gathered, cleansed, transformed, and fed into that predictive model so that it can be used by the applications and the reports. But that way, it puts it in the hands of everybody within the organization. Machine learning doesn't have to be an expensive proposition. Compute services are no longer an inhibitor to innovation. Why? Because of the cloud. Many machine learning tasks do not require data science but experienced data professionals. Why? Because of the large requirement for data engineering around data scientists or around data science itself. Today with the cloud, the scalability and and agility that might be required for data science solutions. It can now be done cheaply and much more easily than it could in the past when you were building out your own infrastructure. Today, there's agility, scalability, reliability, and security that comes with the cloud. And it's no longer a need to build out a large infrastructure to go develop a data science solution. Agility requires you to spend less time, or allows you to spend less time on infrastructure and more on your analytics application, which is really what we want to do. You see these pie charts here that on the left-hand side in the traditional data processing environment, there was a lot of time spent on analytics solutions that were not on the analytics themselves, handling growth, monitoring, provisioning resources. A lot of time was spent on that, and a small slice of the pie was actually spent on doing the analytics work. In the right-hand side, we can eliminate much of that overhead and spend more time digging into our data, which is really what we want to do. That's where the value is, and that's what the cloud can provide to us. Scalability. If we have a solution that needs a lot of resources, we don't have to go out and buy 50 or 100 servers for a short time. We can just spin them up in the cloud. In parallel, there's a elasticity that's involved and that can help us out. That can provide sometimes a very good short-term solution when otherwise we wouldn't have been able to do it. At Dataleer, we spun up 60 servers for a week to provide a solution to a client, when in the past that wouldn't have been possible. Security. These days, security in the cloud is as good or better than most organizations. Data is encrypted at rest and in motion. It's regulatorily compliant. The top security engineers in the world are working for the top cloud providers, and they have upwards of 1,000 security engineers at any of the top cloud providers, more than most organizations, much more than most organizations can claim. And the compliance today, the regulatory compliance is much more advanced. So if data is needed to be at a certain level for security purposes, for compliance purposes, it can be. Reliability. There's built-in disaster recovery, high availability. The infrastructure is state-of-the-art. Again, probably as sophisticated, if not more so, than most organizations. The downtime is minimal. As you can see by this chart, for the three major cloud providers, very little downtime. Less in the last, in 2015, 16, and 17, no more than 700 minutes a year, and that was the peak. You also see that the cloud lowers the total cost of ownership. This is a chart provided that there's a good example of how much money is spent for on-premises software and for cloud computing. Cloud computing, you spend 68% of your costs on subscription fees, 32% on customization and implementation and training. While on-premises, you spend much more on maintenance and IT personnel and hardware. And in the end, cloud computing has been determined to be 77% less than on-premises computing. And machine learning can be fun. We won't go into this in detail because I'll do that in a subsequent video. But we can determine a lot of things about you by looking at an image of you through some commodity APIs that are available in the cloud. We can also determine your political party and a lot of other fun stuff. So what we'll do in a subsequent session is go into some of those things. I want to thank you very much. This is Carlos Bossi again from Dataleer, and I'll be back for more in the future.